Okay, so I think we are live. Okay, so we will try to um do at least three questions from here. We did till this. Okay. Uh, okay, so we did till this. We will try to do at least two of them. Kappa indices and the value you can make. Okay. So first of all, let let's say read the question. Okay, so apparently Kafa came to the restaurant, sat at table. Waiter immediately bought him the menu. There were n dishes. Okay, let me get my copy. Hmm. So there were n dishes. Kafa knows that he needs exactly m dishes, but at that he doesn't want to order the same dish twice to taste as many dishes as possible. Okay. Kefa knows that art this gives him AI units of satisfaction, but some dishes do not go together, and some dishes go very well together. Okay, Kepash said to him, set to himself K rules to of eating food of the following type. Okay, if he eats this exactly before this Y, there should be no other dish between X and Y. Then his satisfaction level raises by C. Okay. Of course, our parrot wants to get some maximum possible satisfaction going to the restaurant. Uh, okay. So we are given first line. I have N, M, and K. Okay. And weird constraints. K is less than N into N minus 1. Hmm. Okay. The number of dishes on the menu, the portion of kefa needs to eat to get to full, uh, number of eating rules. Okay. Second line contains n spaced separated integer ai, the satisfaction he gets from ith dish. Next k lines contains rules. The ith rule described by three numbers, xi, yi, and ci. That means that if we eat this xi right before yi, then kappa satisfaction increases by ci. It is guaranteed that there are no such pairs of indexes I and j, uh, such that okay, so that means all are unique. It is guaranteed that no such pair of indexes I and j, okay, such that xi equal to xj and yi equal to yj. Hmm. Okay. In the single line of output, print the maximum satisfaction that Keffa can get uh, from going to the restaurant. Okay, let's see this example. We are given NMK, okay, which is parent 221. Then we are given an integer, which is AI, the satisfaction he can get. And then I have K numbers, which are apparently the rules. And it is equal to uh, Uh, when I eat, mm, when I eat one, then after one I eat this one. Then does these individual satisfaction count? Apparently not, because when I ate it, then when I try to eat it, I should have a satisfaction of four, but apparently the output is three. So okay, so I can either opt for the satisfaction which is already given to me, or I can go for higher one by following these rules. Okay. And when should I follow these rules? I should follow these rules whenever their sum is mm, their sum is less than this C. If I eat the second dish first, apparently these are the indexes. Okay. One, two, three, four. Okay, so the brute force method would be to get all the possible combination of n. Basically, it will be n factorial. and then just apply a for loop and just see if these kind of tools exists or not. Okay, if they exist, just replace the count by 5. If they don't, then just increase them by this. Hmm. Okay, so we have K rules. We can decide which one to follow and which one to not follow. Right? Yes. So let's suppose there are K rules. Um, we can either follow it or not. Okay, so we need to apply DP on these rules. Okay, so since I can follow it or not follow it. Okay, so let's apply this logic. If I choose not to follow it, okay, if I choose not to follow it, um, and this is also a not. So, so I think we can do it under time limit because uh, eight, 18 raised to the power 4, which is apparently equal to approximately 100,000. So, yes, that's the maximum amount of operation we can do due to this. Okay, so I can either choose if I say that I'm not fulfilling any of it. Uh, will there be any case where I will be forced to, where I will be forced to pick some? Like, let's suppose here. Uh, will there be any case where I will be forced to pick a rule? Let's suppose in this example, instead of one, I would have four. Let's suppose four and four, and two, two, one. Um, and again, I need to eat three dishes, so I can eat this one, and then wait. Okay, so dissatisfaction is apart from these. Okay, that's a complex one. Because we need to take care of whether should we take and which element should we take from here, and which rule we should follow. Okay, so there are two things going parallelly. Okay, when I eat second dish first. Okay, so I fulfill this and I get an extra one also. Hmm. Okay, so here's the approach. Um, Apparently, we need all the possible combination of selecting m elements out of these n numbers. Okay, so apparently these are NCM, and since they are small, so they will be approximately 3 million possibilities. Okay, now out of these 3 million possibilities, um, we need to see if any of it has a rule. Like let's suppose I choose 1, 2, 3. Okay. So ob- obviously I will get a satisfaction of 6. But on top of that, if I satisfy this rule, first rule, so I will get satisfaction of 11, which is a win-win. And there is nothing that will constrain me from choosing the best rule, because obviously if I can, I will do it. Okay, since elements are not actually, you know, there's only one rule for each element. Okay, so if I take 1, 2, 3, then 2, 3, 4. Okay, so apparently I just, let's suppose I take 1, 2, 3. Then I need to check if any of my elements are in this here. If these pairs exist in this or not. Okay, if they do, then it's fine. How do I do it? Okay, so I can check 2 in my M subset if it exists or not. I can check 1. Okay, so it's NCM into M operation, more operations, which is 3 million 80. So it will be around 60 million operations. Okay, so currently we are in a safe zone. If I try to brute force my, okay, apparently this is not a DP question. I think that it's kind of brute force, because I will take NCM elements. Okay, then I will multiply it by M. Hmm, fine. Okay, so let's suppose I take 1 to 3. I will check if there's any. Okay, then I will iterate through all the rules. Okay, I will iterate through all the rules. Um, which is apparently they are max of n squared. So maybe 18 squared. So okay, if then I will check that if they exist or not. Okay, so that's extra m operation. Okay, so there are two operations, iterating through all the rules, which is n squared, and checking if they exist or not. That's O of m. Okay, then if they exist, just apply the rules, and if they don't, then just sum them up and put it in the answer, and then do max of answer equal to whatever we calculated. Okay, so our final complexity NCM into M into N square, which is, I think that it's pretty big because NCM was what maximum NCM could be 3 million, given that M is equal to 9 and N square is equals to 18. So it will be almost 364 into 3 million. Let's just calculate. 18 factorial divided by 9 factorial divided by 9. 18 factorial divided by 9 factorial divided by 9 factorial into, okay, 141 million operations. So it will obviously give us a TLE. This is almost 400,000 operations. Okay, so we need a way. We need a way to. Okay, so where I can, it is possible to optimize. Obviously, if an element exists, I will follow the rule. Okay, that's for sure. Maybe, just maybe, um, I can make a set of these three elements. In fact, I can make a map of these elements. Okay, store all the rules, and uh, when when I get m elements. Okay, so NCM into, then I will take all the two elements one by one. I will select all the two elements one by one. Okay, so that's MC2. Um, then I will check if they exist in map or not. Okay, if they don't, then okay, that's fine. If they do, then just okay. So we have um, NCM into MC2, right? Um, for maximum value, it should be 9 factorial. 9 factorial divided by it's 2. That means 2 factorial into 7 factorial. And this is almost a million operations. Okay, we can do that. We can do that. A million operation can be handled easily. Okay, so our strategy will be first select m elements out of n given ones. Okay, then no, our first step will be to store our rules. Okay, store rules in a dictionary, in a map data structure. Okay, then we will select m elements from given n elements. Then from these m elements, I will select two elements from m, check if they are in map or not. I will do like I will do reverse them this so that if I select one and two, I can check two and one also. Okay, so I will check them two times. Check them if they're map. If they are, then whatever the value of map is, um, just add it. Okay, we don't need to check if they are. I will just add it. If it will not be, it will be just zero. Okay, so I will take my answer to variable. Okay, I will take my answer variable, not answer variable, current variable. Okay, uh, I will add it with whatever the value um, my map suggests. Uh, and and also I will sum all the m elements. I will do it parallelly so it won't take extra complexity. Okay, so then our um, current should be summed here. Now at the end of the loop, like the inner loop, the two selecting m loop, m two element selection loop, I will just check if on I will just update my answer as max of answer comma current. Okay, so that should be my main agenda. Okay, so let's get to coding. What was the problem? Okay, find this is dot cpp. Let me see if I can stream my VS Code. Okay, I think that it's visible now. Hmm. So let's try taking input. We have input in this format. LL, NMK, CN, and M A. Okay. Next up, we will have n elements. So I will store them in a vector. Let's just take n everywhere. I equal to 0, I less than 10, I plus plus array scene, array of I, and L. No, whatever. Now there will be, I need to define a map data structure. In where my key will be a pair. Okay, and let's call it MPP. Okay, so that should do. Now we need uh to we need to check uh, m elements. We need to select m elements from my existing n elements. Okay, okay. So I think that apparently here I need to apply DP. Okay, so I actually need to figure out how to select m elements out of my existing n. Okay, so if I just apply a normal DP, just take not take type of knapsack problem, then I will end up having a complexity of 2 to power 2 raised to the power n, which is good since n is just 18. Uh, it won't be much. Okay, so basically, if I say it's 2 raised to the power 18, it will be almost 9 million operation, which is okay, fine. Okay, so I will say selector. I will define a function called selector, which will give me a vector of integer, or should it? Uh, then what I need is a sequence, right? Hmm. Let me just check real quick. So this is actually a standard code for generating M, uh, you know, subarrays, no, M elements. So the current size equal to L. For Gaussian current, just see out this, okay, then return. But what is current exactly? Is current a 2D vector? No, it's a 1D vector. Okay, apparently. So, okay. So we want current to be a 2D vector so that we can apply our for loop. Yeah, I will simply write global. Okay. So I will have vector n. Apparently, let's just copy it. Okay. And use it in our search. So this is the recursive case. Okay. I will just simplify those. It's ln intem vector. It's also an ln. Okay. Now this will be actually global. Let's say our array would be a vector of LL, and that's actually G, right? So what I want you to do is v dot pushback current, whatever the current value is, just push in our G. Okay. Now this will do the work. Okay. So if I call, get combination, get combinations, we will have vec- elements array, which is apparently array. We need M and start. What does start do? Uh, well, this start variable is kind of unnecessary. But okay, I will just put 0 in there. We need to select m elements starting from 0, and our current will be, let's suppose, a random array. Let's suppose it's q, and this will be vector ln q. Okay, so this should work. This should work. Let's just try real quick. So it got stuck on here. Okay. Array of- Now what? It is getting stuck, apparently. Apparently, we were wrong. Um, our solution was wrong. In fact, we it is actually a bitmask DP problem. So I don't know how do I do it. Okay, that was kind of frustrating. Okay, I'm not doing this repovive. I will go to problem set. Shouldn't have wasted that much amount of time, but okay. In fact, I will not add a DP tag. Um, okay, let's forget. Let's just do this. For div2 V's, right? So, to create a truly festive atmosphere, Santa's helper have opened a factory for producing more snowmen. Okay. Oh, that. Okay, so I actually have done that in my previous contest. Apparently, it was easy. Should I do it again? Mm, it was kind of lengthy though. Should I do it? I don't think that I will do this. I've already done that. Non-descending array. That looks interesting. Okay, so we are given two integers a and b, both of length n. Okay, you can choose any subset of indices, and swap the elements at those positions. Okay, um, okay, that's fine. Uh, a subset of indexes is considered good if after swapping both arrays are sorted in non-decreasing order. Okay. So task is to calculate the number of good subsets. Since the answer can be large, print modulo of this. Hmm. Okay, so apparently what I have is that I have two integers a and b. These are of length n. I can choose any subset of indices and swap the elements at those positions. Okay. A subset of indices is considered good if after swapping both arrays are sorted in non-decrease descending order. Let's suppose this is our array. So in first example, there are two good subsets, 1, 3 and 2. In second example, what? Don't we need it to swap it? You can choose any subset of indices and swap the elements at those positions. Okay, hmm, fine, fine. Okay, so if I swap 1, 3 with this, hmm, what the fuck is saying? 1, 3. Okay, so apparently these are the indexes. Okay, um, these are indexes, right? Yeah, I think so. These are indexes, and okay. So if I swap 1, 2, then I will get 2, 3, 4, which is which will make both of them non-decreasing. So it's good. If I just swap two, if I just swap two, this and this. Okay, then also I will get a non-descending array. Okay, so if can I say that if there exists a one swap between them, there also exists another swap. So always the answer will be in even integers. Okay, in this case, I can either choose to swap it or it's. But what if my answer is already sorted like this? I can either choose not to touch it. Okay. which is apparently 1, 2, 3, 4, 5. It will be paired with, I will not touch anything. 1 to 3 will be paired with 4 and 5. Okay. And 1, 2, 4, 5 will be paired with 3. 1, 2 will be paired with 3, 4, 3. Okay, quite intuitive. So, how should we approach it? Apparently, what I can do is I can decide whether to take that element in our subarray uh, subset or not. Okay. So let's take this example 214 132. When I iterate through 214 and 132 also, I have two options. Either I take two, um, either I swap the first index, okay, um, or don't swap it at all. Okay. So if I choose to swap it, then I also need to check if it will make my array increasing in order. Hmm. And n is apparently 100. Okay. So I can easily go up to n cube. Um, if I choose to swap it, then how will I check if my array has become non-decreasing? Apparently, I think that I need to do some backtracking. Hmm. Let's just suppose we are swapping. Okay. Apparently, I think that a DP solution might help, but I don't really know. One fear or one truth. Hmm. Max and minimum. Interesting. What the fuck it is saying? Um, Apparently, it is saying that we should swap all the maximum and minimum pairs. Then he's saying that we can prove that there is at least one way to make both arrays solve. Okay. Let's suppose we have 4 to 100 and a 171. Okay. Uh, if I take all the maximum element at once, so our first array will be sorted, but our second array won't be. So, is there any constraint on what? No, there's nothing. Okay. So, this method will definitely work. Okay. So, what's the logic? Um, if in an array A we will have a pair, let's suppose AI is greater than AI plus 1. Okay. Then considering that AI is less than equal to BI, okay, it follows that BI is greater than equal to AI plus 1. Okay, that's true since this element is larger, this smaller. Um, no, it's other way around. It's other way around. Let's suppose I have 4 and 2. So 4 is larger, 2 is smaller. And considering that AI is the smaller one out of AI and BI, let's suppose BI is 5. Okay, so definitely it will be definitely BI will be greater than AI plus 1. Okay. This means that whichever of two elements AI and AI BI we place before AI plus 1, it will be greater. whichever of the two elements we place before AI plus 1. Here true. If in array B we have pair bi greater than bi plus 2, then considering that if bi is greater than bi plus 1, okay, let's suppose it's a 3. Okay, then assuming that ai plus 1 is less than equal to bi plus 1. If I assume that ai plus 1 uh, was less than or equal to bi plus 1, which is apparently it's okay. That means ai plus 1 is the smaller one. No, okay, and bi plus 1 is the greater one. It follows that bi is greater than ai plus 1. Okay, this means that whichever of the two elements ai plus 1 bi plus 1 we place after bi, it will be definitely smaller. Okay, so it's saying that whichever the element we can place, it will be definitely smaller. Okay. Thus, if at least one good subset exists, we can always make sure that AI is less than equal to BI. AI is less than equal to BI. Mm, doesn't make any sense. Let's initially swap the elements in those pairs where AI is greater than BI. The answer will not change since 2 raised by n subsets of indexes we are considering will yield the same result after such a transformation, just in different order. Now let's understand which pair of elements we can swap while keeping the array sorted. For each adjacent indexes, there are two possible situations. Either bi is less than equal to ai plus 1, in which case any element I, it's confusing. Imagine of two type 2 pairs. Each type 2 pair merges to segment. We can say 2 raised to n plus k. Quite confusing, but apparently what he's saying that if AI is greater than BI, then I will just swap them. If